Okay, so it's been recorded. All right, so yeah, if you want to have any, if you have any questions, just text me and then I'll get back to you on that. This is NS, right? Who's NS, by the way? Is NS a class rep? I think it's one of the class reps. So anyways, so yeah, that's what IP address does for various organizations and various settings that you might have, even within your home networks. For instance, if you want to set up a small lab at home to experiment with. By the way, we're going to be doing some of these things in your lab session where we build small labs within a confined space using an emulator, packet tracer emulator. You're gonna be using some of these IP concepts. Basically, know how to assign the IP ranges to your computer devices that are going to be set up within your network, so at least they can be able to talk to each other very well. So it's very important that we go through the IP subnet and stuff. I think that's a good part that you guys are going to enjoy when it comes to simulation. But before that, I'm going to let you guys go to the lab session and download the packet tracer, or you can just go online and download the current version, and then we can all practice along. So you can learn some few commands and few tricks here and there about setting up small local area networks you can play with. And like I said, you can, with simulations, they're basically like the real world environment. They just, because of cost issues, they've come up with virtual devices on an application level that you can basically experiment with. So if you don't have the money to go buy the physical devices, which today, technically it's not advisable, nobody can afford for a lab session buying physical devices to set up their system. It's just not cost effective. So we should thank the guys who came up with some of these simulators or emulator softwares that are able to emulate an entire network. So you can basically design an entire network from scratch and be able to test it out, make sure they function according to the way you want it. And then when you have, basically cleared up all of your challenges within that particular implementation, then you can just pick it up and then use it as your production system. That's where you actually go out and buy the physical devices and do the configurations as it was basically done within your lab environment. And then you just, follow through with that and have your production system up and running in no time, because you've already done the simulations, you've covered all the issues, the bugs, the challenges here and there within that particular implementation. So once you carry that onto a production system, it takes less time to get you started or to get you up and running and to get your organization up and running as well. So it's very, very helpful, okay? Anyway, so this is a slide here. Oh, I wanted a PDF, the slide version. Let me open the slide version. Where's the slide? Yeah. The PowerPoint slide. Okay, this is the wrong one. Okay, I'm just gonna, let me go with the PDF for now. All right, okay. So if you haven't learned about IP addresses, the various classes that we have, their notations in terms of ranges, what covers the network part and what covers the node part, just go through the slides. It will tell you all about them. Okay, so you will know when you see a class A IP address, you know the first octet will be the network, and then the last 3 octets will be your node. Okay, and when you take class B, first 2 are your network, the last 2 are your nodes. The small n's represent nodes, which are the host IP addresses, or the the octets that can be used for device IP allocations, or can be assigned, or can be assigned in technical terms, we say be assignable. And then when it comes to class C, you know, it's you have 3 octets that are purely network nodes or network parts of the IP class, and only the last octet happens to be the node part. So you basically have a maximum of 8 bits that you can manipulate when you're within class C IP address range. So it carries, that's why class C carries the minimum range of IP addresses. So for the most part, when you're setting up small networks at home, you will notice that a chunk of your IP addresses will be within a class C range, simply because it has the minimum allocation. But if you're dealing with, say, a mid-sized organization, like a mid-sized company, then you might want to go with a class B IP address, because you're going to have 16 bits that you can manipulate as your assignable IP addresses. And then when you go on a larger scale as maybe a subscriber, telco subscriber, an ISP or whatever, then you want to basically be within the class A range, because that's where you have thousands and thousands and hundreds of thousands of users that requires an IP address. So it's better to use a class A. Class A uses literally 24 bits out of the 32-bit that we have within the IP class that we do have. So it has 24, carries 24 bits. That's a huge stack. So if you want to really know the total amount of IP addresses that can be assignable within a class A, you just take the number of bits for the node part, which is your small n. So there's going to be 8 here, 8 here, 8 here. 8 times 3 is 24. So 2 raised to the power 24 will give you the total number of IP addresses that you can assign to literally anybody within a large-scale IP subscription service. So let me guess. Let me take the calculation. It says that's about what? That's calculator. Where's my calculator? A fancy calculator that can give me the total amount of IP addresses within a class A. So 2 raised to the power 2 exponent 24 2 raised to the power 24 gives you 16 million. So you got 16 million. Well, so a little over 16 million. You got 16,777,216. That's a lot of that's a lot of IP addresses. And if you pay attention very well to your ISPs and the IP addresses they allocate for your mobile devices when you're using pure cellular services, you will notice that they all fall within a class A IP address, simply because ISP deals with millions of subscribers. So a minimum of 16 million is advisable. I mean, they prefer that option. It's the maximum range it can occupy within a given setting or within a given network that it providing services to. So it's ideal to use a class A. But for like GTC, for instance, if you also pay attention when you connect to the GTC hotspots, you will notice that you fall within, you're gonna get a class B IP address. And that's simply because GTC doesn't have millions of users. You guys are in the thousands. So in this case, you're gonna have 2 raised to the power 16, because you have 2 nodes, 2 octets. That's assignable, which is 8, 8, so that's 16. That gives you 65,536 IP addresses. So that falls within a good range. So keep that in mind when you connect to the GTC hotspot, or most of the universities within Ghana. If you go to Legon, if you go to Tech, and you connect to their hotspots, you'll notice that the IP addresses they're going to be assigning to you are usually going to be within a Class B range. That's simply because they're dealing with thousands, maybe 10,000 and 20,000 or 50,000 users. So it's ideal for them to go with a Class B range of IP addresses. And then when it comes to your lab, you fall within a Class C. There's a question here. Please go over finding the number of IP addresses in relations with the nodes. I don't want to be going back to this, otherwise we're not going to get anywhere. I just read the material. You need to read the material, okay? It tells you what the small ends represent and what the big ends represent. It's all in the slides, okay? So just go through it yourself. And if you have any prior questions or whatever, shoot me an email or a text message, and I'll get back to you on that one. But I don't want to go through it too much. I've already covered some of it already. It's really unfortunate that you guys, the new guys, did not go to some of these stuff with your lecturer for Datacom 1. And that's something that I can't really do much about. I gotta cover what I need to cover. That's more important to me. And you do have the material, so please read them. If you have questions, just ask. Okay. Some of them are self-explanatory, but some of them can, if you're going through the first time, you might, and you're not really used to it. You're not used to the concept of IP address, what they're about, and what they're supposed to do, or in terms of giving you connectivity and providing with the right appropriate network set that you need. Then you might find a bit, a bit tricky, a bit complicated. But as you play around with them, you start, we'll go through the labs, you're gonna get a gist of some of these things a lot easier. Because the lab will give you, because it'll be in a practical environment, so when you start assigning some of these IP addresses to various devices within a given network set that you have, you know the difference between the various classes, which one is required, which one is not required. But I've given you some of the gist already in relation to your question in terms of finding the number of IP addresses. Class A is mostly for big organizations that requires a higher number of subscribers. And the notations will tell you the numbers. We use the little n's to represent the host or the nodes for a given network, and then the uppercase N for the network. The network just relates to the domain, the network domain that you need to be in, the broadcast domain that you can be in before you can be able to talk to other devices. So it means that if two machines don't have the same network IP nodes, then chances are they can't communicate. So let me just go back to this real quick. So like for instance, this one here, if you have an IP address in a class A, and then you have a machine with a class A IP address, you have another machine with a class C IP address, obviously you can tell that you're gonna have different network IP ranges. Class A has got only one network, it's a big N, but class C has got three networks, or three octets that form the network. So obviously they're gonna be within different ranges, so you can't talk. So class C and class A will not be able to talk, or those two machines will not be able to talk simply because they are within different network domains, okay? So they're not gonna be able to talk. But to make it talk, if you want the two devices to actually talk, two devices on separate class of IP addresses, that's when you introduce what you call routers. Routers are designed to forward packets from one IP class to another IP class, or from one network domain to another network domain. and it has a way of basically handling all of that. And that's mostly true public IP addresses. Like I said, we'll get into some of these in a practical environment so you can understand a lot better. Somebody says, why is class D and E not used? Yeah, those two are reserved. They're reserved for more or less experimental basis. It's just when they design the IP classes, they reserve these two for purely experiments. Most broadcast services use the class E's. Most big labs, like big scientific lab organizations, will use some of these class D or class E IP address. So they are reserved. The answer to your question is the reason why they are not being used for more or less device communication on a given network is because they have purely been designed to be reserved for research or experimentation purposes. Okay, so that's the reason why they don't. For the most part, we only use class A up to class C. This is the three main class of IP you're going to be working with on for as long as you're alive anyways, or for as long as data communication and networking is all about. Okay? All right. There are some cool stuff that you need to understand within the various class of IP addresses. Okay, so I'm going to start from here. Let me see, I'm going to start from here. Okay, these are class 4 standards. Class 4 standard determines how well you can basically subnet an IP address within a given network domain that you have. They're essential for IP subnetting, mostly because we've identified that sometimes we abuse IP addresses simply because of lack of management or understanding of what we want to implement. So you have maybe a student will say, I want to set up a small lab, and it involves only about, say, 10 machines. And then they use the entire class C IP address of class C IP addresses with the 8 bits that they have, which is, then you have with 8 bits, 2 raised to the power 8 gives you 256. I'm not mistaken, but 2 of the IP address have been reserved. So technically, that signable IP address is 254. So 2 raised to the power 8 is 256, exactly. And 2 of those IP addresses have been reserved for broadcast and network. So the only assignable ones are 254 because 256 minus 2 gives you 254. Okay. So now if you say you want to set up a lab and you only have 10 machines and you use up class C IP addresses without subnetting it, you'd have 10 out of what? 254. It means you're going to have an excess of wastage IP address of what? 240 what? 44, right? Because it's 10 out of 254 is 244. So you're going to have just 244 IP addresses being waste and nobody's using them. So to avoid some of these things, they came up what you call the class 4 standard of IP addresses. So we can decrease the number of wastages. I think the whole concept behind the wastage or the whole concept of class 4 standard is because of the fact that the IP version 6, by the way, there are 2 IP versions, and obviously there are 5 classes of those ones anyways. There's version 4 and version 6. Version 4 is what is mostly used today, even though other organizations have jumped onto the version 6. But for the most part, you're going to be dealing with a lot of the version 4. But version 4 is quite limited. If you do the calculation, there are 32 bits that an IP address occupies because there are 4 octets. So it's 4 times 8. There are 4 octets of 8 bits each. So you have 4 times 8. That gives you what? 32. So if you want to find the total IP addresses within that 32 bits, and it's 2 raised to the power 32. If you do the math, you're going to realize it's about 4 billion. 4 billion IP addresses that we have. Now, if you think about it, you might think 4 billion is a lot of IP addresses, but technically it's not if you're dealing with devices. The internet is made out of billions or over millions and billions of what? Network devices, and they all need IP addresses. And besides the internet itself, you also have the end users like you and me using cell phones, laptops. Some of us even have multiple network devices on us on a day-to-day basis. Research shows that within the next few years to come, maybe the next 5, 10 years to come, a lot of users are going to be carrying at least 2 or 3 network devices on them wherever they go. And already since you see that most of you are carrying cell phones and tablets or laptop with you when you come to class. So that's 2 already. So you can imagine in 10 years time, you might want to incorporate maybe a smart watch that needs its own IP address, or you might have wearables that need their own IP address. And that would add to all of those network devices that need IP addresses not to communicate. So, we get in there, obviously, it's pretty obvious. Already, like I said, most of you are using 2 gadgets. You carry them with you everywhere you go. Some of you have 2 cell phones, look, even that, and tablets or whatever. But like I said, the statistics shows that prediction shows that in the near future, in the next 5-10 years to come, most users across the globe will be carrying with them at least a minimum of 3 network devices wherever they go. So that's pretty good, because it means that we basically elevating our technologies or our conveniences in terms of how we make our life comfortable or smoother or much more efficient. I don't know I'm not sure what those are good words, but technically it's just want to make our life much more comfortable, basically. So the more we want to get comfortable, the more we have to engage a number of devices. Today, comfortability is all about, having the right gadgets, making sure you can access information as and when you need it, because some of them revolves around either your social interactions, or it could be business, which is very standardized in terms of making money or making sure you are up to the same level with your customers or with your clients or whatever. So having some of these smart devices on you is very, very essential to get you by. So anyways, yeah, you're gonna be carrying some of these gadgets with you on a regular basis: your cell phones, your tablets, your laptops, and all of these, your wearables, your smartphone, or a smart glass, or even your car would have its own IP addresses, so you can actually navigate through things, have communications within the car while you're in the go or while you're driving, or even at home, have smart homes where you have your refrigerators, your TVs, your ACs, your security systems, all being interconnected. And all of these requires what? IP addresses. So obviously, there's going to be a time that, it's going to be a point in time where even that whole 3, the minimum of 3 will jump to even a minimum of 10. Because if you include the wearables and your smart homes design stuff, you're going to notice that you need a lot of IP addresses. So coming back to the 4 billion IP addresses, like I said, if the internet alone covers millions and billions of devices, you start adding some of these other gadgets, personal gadgets onto it, you'll notice that the 4 billion is just not enough. So that's why the class the IP version 4 is not enough to address today's needs. So they came up with a version 6, which can accommodate about 120, no, about three, let me see, that is about 64 bits, right? So let me see. So 2 raised to the power 64, if I'm not mistaken, is it 64, 30, or 128? It's 128, sorry. So 2 raised to the power 128. Yes, that's 3 trillion. Ooh, man, that's huge. So 3 trillions of IP address. Now that can accommodate every need. Uh, for as long as you're alive, even before you until you die, that can accommodate all of our needs. So that's one of the reasons why they came up with the version 6, because version 6 can carry 128 bits, whereas version 4 takes only 32 bits. Version 6 carries 128 bits. So if you want to find a total IP ranger, just say 2 raised to the power that number of bits. So 2 raised to the power 128 gives you 3 trillion, 3.4 trillion of IP addresses. That's massive, man. So that's designed to accommodate for today's interconnectivity that we have. So a lot of your Internet of Things, your wearables, your smart gadgets or whatever you have are all going to have IPs of their own. Even you as a human being, you have your own IP, maybe a chip implanted into your body that has got its own IP address. So basically, give you a good geolocation wise, or be able to use it for all kinds of stuff. It could be for medical, just you can check your vital statistics health wise, or know wherever you are at a given point in time, in case you get lost or you've been kidnapped or hijacked or whatever. They can easily locate you via some of these embedded chips within our bodies or whatever. If you go to Sweden and some of these Scandinavian countries, some of them have already started engaging in some of these things already, where they embed microchips with IP tags on them, so they can be able to use that for a number of things. It helps them access various financial services, plus medical services, and what have you. And some are pushing the level of, of how interconnectivity should be. In Africa, when you talk about some of these things, they start talking about the wizards. We're talking about witches and wizards and all of that. Now, it's just the way the future is moving. And eventually we'll also catch up some of these things. We start having implants on our bodies for a number of reasons. Yep. Can you guys imagine having an implant on your body that can be able to use for maybe your bank transactions? So when you go to ATM, you don't have to carry your ATM cards anymore, or even have your fingernails anymore. You just have a chip in your palm or whatever, and you just scan it to a screen on the ATM machine, and it's able to access your bank account and be able to use that to withdraw your money or address a financial, transaction or whatever. So it's we're moving up on a good scale over here. So, anyways, the limitations of class IP version 4 is what led to the class 4 standards of IP address subnetting. So within that, they say that if you feel like you're not going to be using too many of a given class of IP addresses, then find a way to subnet it where you can limit the number of wastages. And this is where some of these concepts comes into play. So the current class 4 standards rules are that the original network ID, which is usually your network for a given class. So in this case, this is probably a class B IP address, simply because it has 2 of the octet being taken up as the network, just looking at it. So that's obviously a class B in terms of its allocations that you have. All the classes of IP address from 1 to 3, or the major ones that we use for our day-to-day networks processing,